Differences between weak and strong acids. A weak acid dissociates incompletely, releasing only some of its hydrogen atoms into the solution. Thus, it is less capable than a strong acid to donate protons. These acids have a high pKa. This acid undergoes a reversible reaction. If the concentration of undissociated HA is negligible when the reaction is at equilibrium, the acid is said to be strong. The pKa of this acid is low. This reaction is non-reversible. What is a buffer and how does it work? A buffer is a solution that can resist pH change upon the addition of an acidic or basic components. A buffer is able to neutralize small amounts of added acid or base, thus maintaining the pH of the solution relatively stable. When hydrogen ions are added to a buffer, they will be neutralized by the base in the buffer. Hydroxide ions will be neutralized by the acid, and these neutralization reactions will not have much effect on the overall pH of the buffer solution. In the experiment, what we're going to do is that we're going to get this rid up here, and we're going to rinse it in the DI water so we can use it later for the experiment of the pH. Now with we rinse the calibrator, we're going to get it into one of the buffers, buffer number 7, and we're going to measure the pH of it. Okay, got it. The green liquid inside the beaker is the buffer 7, and this one is the buffer number 4. Now that we've rinsed the calibrator, we're going to put it inside of one of the buffers and calibrate it first, and then we'll do it for the second one. We'll put the calibrator inside the buffer 7. Touching the red box, you get one of the options to go to calibrate. Calibrate now. Start with 7. Keep. Now stir this a little bit.
Now we have to remove it from the buffer 7 and go and rinse it off so that we can calibrate with the buffer 4. Now we'll put the electrode inside the buffer 4 and stir. We insert the value 4 here since we know that that's the pH of the buffer 4. And we hit keep. And now calibrated. Now that both of the buffers have been calibrated, we're going to put the electrode inside one of the buffers to double check our calibrations. And as we set our buffer to calibrate at 7, now it's reading 7.01, so we've done a pretty good job calibrating. Now we'll rinse our electrode again with distilled water.
So these are going to be the concentrations that we're going to be using today in the lab experiment. Acetic acid, hydrochloric acid, orange juice, apple juice, sodium hydroxide, and NH4OH. We're going to be measuring the pH of the first one, which is acetic acid. But first we're going to rinse it again with some of the distilled water. Now we're going to measure the pH of the acetic acid. This is going to be the pH of the acetic acid, which we're going to be putting in the table.
Alright, now we're going to do the rest. And now we're going to record the rest. We've all been recording.
This procedure that we just did, you're going to be doing it for all the other concentrations that you have left. Now that we have finished with the experiment, we need to wash the electrode here of the pH meter by rinsing it with distilled water, DI water. Making sure that the lid is nicely tight. Finally, we just turn it off with the button